we have to solve this initial value problem. The first step is to rearrange this equation. Let's subtract x from both sides. So we have that x squared plus 1 times y prime plus x times y equals minus x. And now let's divide with this. Then we have that y prime plus x over x squared plus 1 times y is equal to minus x over x squared plus 1. We can clearly see that p of x is this term. So p of x is x over x squared plus 1. To get the integrating factor, the first step is to integrate this expression. So we have to calculate the integral of x over x squared plus 1 dx. We can use u substitution. So let's say that u is x squared plus 1, then du will be 2 times x. So this integral is nothing else but 1 over 2 times 1 over u du. This is, of course, is nothing else but 1 over u times the logarithm of the absolute value of u. And now we have to go back to the other variable. So this will be 1 over 2 times the logarithm of x squared plus 1. And this further equals to the logarithm of x squared plus 1 raised to the power 1 over 2. And the second step to find the integrating factor is exponentiating this. So we have to calculate the exponent of the logarithm of x squared plus 1 raised to the power 1 over 2. And that's gonna be the x squared plus 1 raised to the power 1 over 2, which is nothing else but the square root of x squared plus 1. So we have that this is our integrating factor. Now we have to multiply both sides of the equation with this term. We get that square root of x squared plus 1 times y prime plus x over the square root of x squared plus 1 times y is equal to minus x over the square root of x squared plus 1. We can clearly see that this is nothing else but the square root of x squared plus 1 times y is a derivative, and the right hand side will be minus x over the square root of x squared plus 1. Now let's integrate both sides. So the square root of x squared plus 1 times y will be the integral of minus x over the square root of x squared plus 1 dx. We can use the same u substitution that we did here, and we get that this integral equals to minus 1 over 2 times 1 over the square root of u du, and this is of course gonna be minus the square root of u plus c. And now we have to plug back this to the square root, and we get that this equals to minus the square root of x squared plus 1 plus c. Now we have to divide with the coefficient of y. So we have that y equals to minus 1 plus c over the square root of x squared plus 1. And this is the general solution of the equation, but we also have an initial value, and that initial value states that y is 2 when x is 0. So let's plug back these values into this. equation. From here we get that 2 is equal to minus 1 plus c over 1. And we can easily see that c must be 3. And to get the solution of the initial value problem, we have to plug that c value back into this equation. So the solution of the initial value problem will be y equals to minus 1 plus 3 over the square root of x squared plus 1.